Hello and welcome to today's daily challenge. Let's begin our question. Okay, let's see. Question 1539, kth missing positive in number. So given an array R of positive integers sorted in a strictly increasing order and an integer k, return the kth positive integer that is missing from this array. Okay, so we have an array 2, 3, 4, 7, 11, and the missing integers are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the fifth missing integer. Okay, so yeah, this is an easy level question, so let's just begin to the implementation. We have, let's call it counter equal to the first number, and we will also have, so this is what I'm thinking. We have a counter that is going to be incremented each loop, and then we have the actual array that has either a missing element 3, 4, 7, 11, and what we have to do is if counter is not, so let's have another sort of let's have another integer or another pointer representing the iteration of our array, and as we are incrementing this guy as we're going through the for loop, if counter is not equal to, this is counter, if counter is not equal to an element of the array in R, then we increment counter to the next, and we increment counter and say R pointer is equal to 0, and while counter, let's see, while R pointer is less than length of R, and let's say, and K is greater than 0, we're going to say, let's get rid of this for now. K is greater than 0, that's going to be, K is going to be decremented each time there's a mismatch between counter and the value that our pointer is pointing at. So if counter does not equal R pointer, then we increment counter, we decrement K, and we leave our pointer the same, hoping that the next time counter is incremented, it's going to be a match, and else if it is no match, here there's going to be, if there is a match, then we also increment this guy, but we also increment pointer. And we can see from this that maybe counter should be incremented regardless of the for loop, but let's just leave it here for now. And finally, as we're doing this, K will at some point be equal to 0 because we keep on decrementing it. And when that is all done, let's see, what is going to be the missing, the kth missing element? So when k is 0, we can simply return counter, I believe. Wrong answer, expected 9. Index out of range. Okay, so index out of range. Our pointer is pointing to an element that does not exist in the range. That is probably because if the input is smaller than, if the length of the input is smaller than k, at some point this condition is going to be executed with an R pointer that's been incremented to a significantly larger number, or just a larger number than length. So we also have to say that R pointer is less than length of R. Okay, hold on 1 second. Let's So I think I have everything in place. I'm just a little bit lost as to what is going on. We have in the case of a mismatch, no match, we increment the counter to the next value. We keep the R pointer the same, and we decrease k by 1, indicating that we have hit a mismatch. So all good there. And when this is happening, okay, the next iteration, we have 2 and 3, 2 and 2. That is going to be a match for both counter and R pointer. And in that case, we don't increment k or decrement k at all. We just continue off here. Same goes for 3, same goes for 4. As soon as we hit 5, our pointer is actually pointing to 7. K is pointing to, or k is at this point 4. And there's no match, so we increment counter by 1 to 6. We we decrement k to 3 now. So 1, 2, 3, 4 to 3, and we exit the loop. Then we hit it again. It's going to be done for 6, where 6 is not equal to 7, so we execute this counter. Let me remove this from counter plus equals 1. What is going on? R pointer. If there's no match, then we decrement k. We don't increment R pointer. If there is a match, we increment R pointer and we increment counter. Should I not be returning counter at all? Should I just be returning some ret val? Let's see, what is the return value? The return value is the number that is missing the number, so that should be counter, return counter. The problem here is that why is it that, what happens when k reaches a, what happens when we reach the end of our pointer, but k has still some, k still hasn't been exhausted? Would we add it to -1? Okay. Okay, nice. Yeah, I don't know. This is some weird adjustment that needed to be done. I wonder if we can improve this somehow. Okay. Sorry, just give me a second. I'm hoping that the explanation here is pretty reasonable. I missed the edge case that we have exhausted our pointer and haven't exhausted k yet, in which case whatever numbers, whatever k is left to, we just we add it to counter, because array doesn't actually go that far. So, and the -1, I'm pretty sure that's just because of the for loop, essentially, or the while loop. We might be exiting one before k has been decremented, so that's why. Let's see how, if we can improve this. I don't know if, does this, could order here matter? No. K bigger or equals to 0. Okay, and then in that case we don't have to. If k is bigger or equal to 0, then yeah, I would probably just stick with this then. What can we improve? I mean, this is silly. I'm just... Yeah, I actually don't know what the best solution is, but a 95 is good enough for me. And I hope that this makes sense. We have a counter again that is emulating an array with continuous positive integers. We have an R pointer pointing at the indices of the input R array, and we leverage the k, which is the kth missing positive integer, the k variable, and the R pointer, which is the pointer of the R, of the index to our input array. We leverage those two to create a loop where we increment counter sequentially until we and conditionally either subtract decrement k or increment r pointer. So in the case that it's a mismatch, we reduce k by 1, indicating that we have missed a positive integer. And in the case that we have found a match, we simply increment the r pointer by 1, preparing us for the next encounter of the next positive integer in the array, and unconditionally increment counter, which is just that emulator of the continuous positive integer array. And while we're doing all of this, we are keeping track of counter, which is going to be at the end of the day pointing us to the value that's being missed in the array. And the plus k is a condition where we have exhausted the r pointer, meaning that we've reached the end of the array, but k is still not 0. So there's still some number of positive integers that we want to take into account, and that's where we add k, and because of the nature of this while loop, we have to subtract 1. So feel free to use this. Pretty simple. Thank you for watching. Bye.